Hey everyone, this is our review video for graphing quadratics in all forms, and actually we're mainly looking at two forms, vertex and intercept, previously from some other papers. So let's just make sure that we can do our vertex forms. Okay, so for instance, whenever we look at something like this, 1/2 x plus 1 squared minus 6, our vertex is going to be minus 1 minus 6. Let me see if I can't bring this down just a little bit. Okay. Because it's always opposite HK, so it's going to be opposite of positive 1 to be negative 1, 6. So negative 1, negative 6 down here. Alright, and then from there, our domain will be negative infinity to infinity, as always. This is positive, so it's going to open up, and we can do a little table to kind of see what's going on. It does have this half here, so it's, instead of going up one, over one, up one, it's going to go over one, up a half. But you can find that out by plugging in 0. If you plugged in 0, you get 0 plus 1. 1 squared would be 1. A half times 1 would be 1/2, minus 6 would be negative 5.5. So all I did was plug in 0 to get some more points, and I got negative 5/2, and we know that this is also our axis of symmetry, so we get something like this also. Okay, so our range, remember, it starts from the bottom and goes to the top. The lowest point that this goes to is negative 6, and it goes up to positive infinity. On these, you will not have to do the x-intercepts right now, because you'll be given the graph and you'll see where the x-intercepts are. The y-intercept, though, you will always plug in 0. And when you do that, we got negative 5/2 back. So our y-intercept is 0, negative 5/2. We do have a minimum because it bottoms out. Our axis of symmetry is x equals negative 1, so it's the x value of the vertex where it gets cut in half. It's in behavior. As x goes to the right, it's going up. As it goes left, it's also going up. So as x goes to positive infinity, y values are going to positive infinity. As x goes right, it's going up. And as x goes left, negative infinity, the y values are also going up. Now, I've shown y'all my trick for getting the intervals really easily, increasing and decreasing. Okay. So on this, if we had a number line, forever over here is negative infinity, over here is positive infinity, and then it gets split up by negative 1, that might be a little hard to see, right here by our axis of symmetry. So on the left side, this graph is going down, it is decreasing, and on the right side, it is increasing. So our increasing interval is, so I'm actually going to write these down here. Our increasing interval is from negative 1 to infinity. And our decreasing interval is from negative infinity to negative 1 on the left side. And that's all you have to do for that one. Okay. For number 2, there's nothing in the parentheses here, so h is not there. Here is k. If h isn't there, then that means that what you have is 0 for h. So your vertex here is actually 0, 6. 0, 6. Go ahead and plot that. That means our axis of symmetry goes right through there. The domain will always be the same, negative infinity, infinity. Let's plot some points. Always start with your vertex. All right, let's plug in 1 because that's going to be the next thing. Although we do know that this is -3, so it's going to go down. It's going to point down, and it's going to go over 1 down 3. But just to confirm, if you plugged in 1, you'd have 1 squared is 1 times -3. And then -3 plus 6 would be +3. So that's going to come out to be -3 plus 6. And you can do that in your calculator too. And you wind up 1, 2, 3, something like this. 2, 3. So it gets real steep, real skinny. It's stretched out like that. And by the way, that's the same thing on this side too. So the range goes from bottom to top. It starts at -infinity. The highest y value it goes to is 6, so 6 with a bracket. Again, x-intercepts, we'll talk about those when we get back from the break. But y-intercepts, you always plug in 0. Sub it in. Okay. So if I put 0 in for here, I'd get, well, 0 squared is 0 times 0, that would go away. I'd be left with 6. 0, 6 is what we would get. So that's your y-intercept. This has a maximum because the top's out. Its axis of symmetry is x equals 0. In behavior, as it goes to the right, it's going down. As it goes to the left, it's going down. So as x goes to the right, the y values also are going down, -infinity. As x goes to -infinity to the left, the y values also go down. So the nice thing about quadratics is once you know one in behavior, it's the same thing for both sides. And then do the trick for your increasing and decreasing. Draw your little number line, -infinity to +infinity. You've got your axis of symmetry here, which is 0. On this side, it is increasing. On this side, it is decreasing. So it's increasing from -infinity to 0. It is decreasing from 0 to +infinity, sorry. Let me erase that. That's it. And we won't worry about positive and negative right now. So let me know if you have questions for number 3. I'm going to send the key out, but that's going to be the case there. All right, moving on. Write the functions from the widest to the narrowest of their corresponding graphs. I think yours on here has the parentheses right here, which it should be, and that shouldn't be there. But remember, widest is from your a value has to be between 0 and 1. So in other words, it's that fraction or a decimal. That's going to give you your widest. The narrowest is going to give you when a is greater than 1. So we've got 4 and understood 1 and then 1/5. Since this is 1/5, this is going to be our widest. This is going to have the look of our parent function. And this 4 is going to be really stretched going up. So this is 1, 2, 3. And that's it for those. For number 7, for the graphs to the right, describe how the graph of f of x was transformed to the graph of g of x. So how was this turned into this? Very simply, we just moved it down. Okay, 1, 2, 3, 4. Down 4, and we stretched it. Or I'm sorry, shrunk it, compressed it. Write an equation for f of x. That's easy because we have 0, 6. Remember, x minus h squared plus k. Okay, our vertex here is 0, 6. So if you did that, By the way, A is normal here over 1 up 1, so don't worry about A. You'll have x minus 0 squared plus 6. So this is just going to be x squared plus 6. Now C, I'm going to leave for y'all to have kind of as a bonus, because the thing that's different here, you'll be able to find your vertex, but you've got to count what your coefficient might be. So don't stress too much about that one. What you do need to look at is number 8. The parent function f of x equals x squared is reflected over the x-axis. So what does that mean? That means it's going to become negative. Vertically compressed by a factor of 1/6. So we have to put that 1/6 on the front. Shifted right, that's inside the parentheses. So we've got to do opposite. And down 23, so we have to subtract. So a x minus h squared plus k. It was compressed by 1/6. It is also reflected, so it's negative x minus shifted right 12. So you would think plus 12, but it's actually going to be minus 12, because remember we do the opposite way. And then down 23. Okay, the parent function f of x equals x squared. It's vertically stretched by a factor of 2. So if I had x squared, I know I'm going to stretch it vertically by a factor of 2. It's shifted left 2, so then it's going to become this. So 2, anytime you go left to right, put in parentheses, x plus 2. It's going to be opposite. And then that's it. Okay. So moving on to the next page, or the back. All right, so I know it's hard to see on here, but match each graph with one of the following functions. The easiest way here is it looks like they all have different vertices. So just get the vertex of each one. This one here is -8, -3. We can find that real quick. Can't be this one. That's at -3. -8, -3. It's positive, so this is going up. So that is A. Moving on to B. All right, so you see your inverse is going to be +8, 3. So if you look very easily, over 8 up 3. There it is for that one. C, okay, this one it's going to be -3, 8. That's your vertex. And you go over -3, +8. Oh, sorry, that's B. This is C. All right. Write each standard form equation in factored form. Identify the x-intercepts. So we won't see ones that are hard trinomials, the not so nice ones where you have to do a times c and blah, blah, blah. But you do need to know how to do your basic factoring. So like this one right here is a difference of 2 squares, which is going to be 11x minus 13 and 11x plus 13. And then when you want to find x-intercepts, set these equal to 0. So you'd have 11x plus 13 equals 0. Okay. Let me write that out. All right. So minus 13. You'd get 11x equals -13. Divide by 11. So x would equal -13 over 11. And since they're the same, also positive 13 over 11. All right. Now, for the next one, this is a trinomial, so it's very easy. It's what times what is 32, but adds up to -18. And that's going to be, oh, sorry, I'm writing the answer out. 16 and 2. But since it's -18, these both have to add up to -18. So you get x minus 16 and x minus 2. So remember, set these equal to 0. What minus 16 equals 0? X equals 16 here, and x equals 2. And then finally, for this last one, this is just a GCF, so we can take out a 5 and an x, I would have x plus 9. What would make this 0? Well, 5 times 0 would be 1 right there. And then x plus 9, what plus 9 would give you 0? X equals -9. So look more for ones like 13, 14. And just make sure if you see this right here or right here, you can get your zeros from there. 15, explain why the quadratic function of f of x squared plus 9 does not have any x-intercepts. What is the maximum number of x-intercepts a quadratic function can have? Well, if you graph this, it's going to be moved up, so it won't cross the x-axis, so you can write that. And then, what's the max number of x-intercepts a quadratic function can have? That's going to be 2. Okay. Find the vertex and identify it as a max or a min. Well, the vertex here is going to be -3, -6. This is pointing up, so we will have a minimum. I'm not too concerned for ones like B and C. Let's just take a look at C, just in case you need to factor some of these. Or well, let's do C so that we can do the do your intercept form. Factors of -12 that add up to 16. What is that going to be? Ooh, I don't know if that one factors, does it? 4 and 3, no. 6 and 2. Yeah, this one's not going to factor, so we haven't seen this one, so cross out B and C. We'll come back to those. Okay. Using leading coefficients, analyze a graph of your standard form. It doesn't really matter what form it is here. Circle the appropriate answer each set. All right, if A is negative, it's going to open down. And since this is greater than 1, this is going to be narrower. If it's 2, it's going to open up. That will still be narrower. 1/3 is going to open up. It's positive. And it is going to be wider. And be careful here. This is actually -2.5. That's going to open down. That's actually going to get wider, even though it's a fraction. Okay, finally, to the last two problems. To the right, you'll find a table of values for a quadratic equation. Determine the x and y intercepts. So remember, x-intercepts are when y is 0. Okay, so -3, 0 is our first one. And there's another one at 1, 0. And your y-intercept is when x equals 0. You always plug in 0, right? So we have a y-intercept at 0, -3. Your vertex, from a table, look where everything reflects. So 12, 5, 0, -3, -4, -3. Oh, I'm seeing a number again. That one to that one. 0 and 0. So it looks like it reflects through after -1 and -4. There's our vertex. And our axis of symmetry is x equals -1. Okay, the equation h of t, and I'll tell you what you need to know about this type of problem. This represents its height and the ball after t seconds. What's the maximum height the ball reaches? Very simply, if you're trying to find a max, remember our max and mins are always the vertex. Okay, so make sure you know that. So I know this is a longer video, but there's a lot of details in here. So just go through it, make sure you know your characteristics, and you can do all those and pick them out. And that's all you need to know. Let me know if you need any help.